Welcome to the deep dive. Today we're tackling what's often a massive headache: getting stable, genuinely high-speed internet when you're out on the water, miles from anywhere.
Exactly.
We're going deep on Starlink Maritime, and specifically looking at the Flat High Performance Antenna, the FHP.
Right. And our mission today really is to get past the marketing gloss. We want to distill the hard facts. We're talking key tech specs, actual real-world performance, and maybe most importantly, the installation and network strategies you need to get connectivity you can actually rely on at sea.
Yeah, because before we even get to the solution, we have to understand the problem, right? And reliable internet at sea, it's not just one issue.
No, it's like 5 things hitting you at once.
Exactly. You've got the boat constantly moving, pitching, rolling, turning. That alone can drop the signal. Then there's the saltwater corrosion just eating away at everything.
Relentless.
Plus physical blocks, masts, domes, other structures getting in the way of the signal. And of course, extreme weather, intense heat, especially that sun reflecting off the water.
And it's all happening when, let's face it, patchy internet just doesn't cut it anymore.
Right.
People need real-time navigation, they're doing remote work, video calls, streaming, you name it. So the FHP, its core value really is that it's the only Starlink antenna built for full-time use while moving and for those long international trips.
Okay. It's designed specifically to handle those 5 stressors we mentioned.
Precisely. It's like an armored self-aiming system built for that job.
So let's unpack that. Why is this flat high-performance model, the FHP, so much better suited for motion compared to other Starlink dishes?
Well, the big difference is its design. It's flat, low profile, which means less wind resistance, obviously. But crucially, it has this incredibly wide field of view, 140 degrees.
140 degrees, that sounds significant.
It's huge. It gives the antenna a massive window to find and stay locked onto the satellites, even when the boat's making sharp turns or rolling heavily.
And that's especially important with Starlink's LEO satellites, right? Low Earth orbit. Maybe explain briefly why those handoffs are so fast.
Sure. So unlike the old geostationary satellites that kind of hang in one spot in the sky,
Right.
LEO satellites are whizzing overhead. They're moving fast. So the antenna has to constantly switch its connection from a satellite that's moving away to one that's just coming into view.
And that happens often.
Oh, yeah, sometimes every few minutes. That 140-degree view is specifically optimized to minimize the signal drops during those super fast handoffs. It helps keep the connection stable even when the vessel pitches suddenly.
Okay, that makes sense. And the speeds people are actually seeing offshore, they're pretty impressive. The sources mentioned commonly getting 40 to over 220 megabits per second down. That's quite a range, though.
It is a range, yeah.
What makes the difference between a 40 megabits day and a 220 megabits day? Is it just how busy the network is?
Network congestion plays a part, definitely, but it's also about your latitude, how many satellites are overhead at that moment, and how close you are to a ground station on land.
I see.
But even that floor, that 40 millipays down, is still really robust for being a sea. It handles video calls, remote desktop, no problem. And the latency usually stays below 100 milliseconds.
And that sub-100 millisecond latency, that's kind of the magic number, isn't it?
It really is for professional use, yeah. Keeps things feeling responsive.
Now, beyond the raw performance, the physical mounting seems really important for actually getting it on the boat properly.
Oh, absolutely critical. Because it's flat and has low windage, you can mount it flat, on a rail, on a mast. You've got options.
Okay.
And this flexibility makes it much easier for installers to get it mounted high up, and crucially, above the sweep of the radar beams.
The radar issue. Why is that so important?
Well, 2 reasons. Performance, you don't want the radar interfering with the Starlink signal. But even more critical is safety. You need to be able to run your radar and your internet at the same time without one messing with the other. Getting the antenna placement right is key for that.
Right. Makes sense. Okay, let's shift gears a bit into the tech specifics.
Sure.
People are now choosing between the Gen 2 FHP, which has been around a bit, and the newer Gen 3 model.
Yeah.
How do you decide which one fits your boat, your needs?
The quickest way. Look at the router and your network needs.
Okay.
Physically, the Gen 3 is a bit slimmer. A touch lighter panel's about 5.2 kilos versus Gen 2's 5.9 or so. But the real upgrade, the generational leap, is in the networking hardware it comes with.
Let's focus on that Gen 3 networking then. It's got a tri-band Wi-Fi 6 router, which is already an upgrade. But the big deal seems to be the dual 2.5 gigabit Ethernet ports, right? Built in.
Exactly. That's huge.
What does having those faster Ethernet ports actually let you do on the boat?
It means you've got serious bandwidth potential inside the boat's network. Think about onboard servers, maybe high-volume data tasks like streaming multiple 4K feeds, high-res CCTV monitoring, or just supporting a really complex network on a larger yacht.
Ah, so the antenna might be pulling down 200 Mbps, but the old router could be the bottleneck.
Precisely. With the Gen 2's older Wi-Fi 5 setup and needing an adapter for Ethernet, you could hit that bottleneck. The Gen 3 gets rid of that limitation, gives you way more headroom, better mesh capability for larger setups too. It's more future-proof.
Okay, so bottom line, if you've got a boat that moves lots of users, high data demands, maybe you're doing link bonding, Gen 3 is probably the way to go.
Absolutely. You need that performance headroom. Gen 2 is still perfectly fine if your use is maybe lighter, more coastal, or if budget's a primary concern. It's still a very capable unit.
Got it. Now, durability. You mentioned it's built tough. Let's talk temperature. The specs say the FHP works from -40°C up to +60°C. That's quite a range.
It is, and that +60°C maximum, that's 10 degrees higher than the standard Starlink dish's 50°C limit.
Why is that extra 10 degrees Celsius such a big deal in the real world, on the water?
Think about a black antenna sitting on a bright white deck in the tropics.
Yeah, reflecting all that sun.
Exactly. The surface temperature can get incredibly hot. That extra 10-degree margin prevents the unit from throttling.
Throttling, you mean slowing down?
Yeah, the system deliberately reduces performance to avoid overheating and damage. So when a standard dish might start to slow down because it's hitting its thermal limit, the FHP, with that higher tolerance, just keeps performing. Critical in places like the Caribbean, the Med in summer, the Persian Gulf.
Okay, that makes a huge difference. And managing that heat takes power, right? The FHP uses quite a bit more electricity, 110 to 150 watts compared to 50-75 for the standard.
It does. That higher power draw supports the robust thermal management. But it also fuels other features, like much better snow melt capability.
Snow melt?
At sea.
Well, maybe not mid-ocean, but for vessels operating in colder climates, near coastlines, or even stored over winter, it has 87% more power for melting snow or ice, 75 millimeters per hour versus 40. It's all part of that overall robustness. It needs that power budget to handle the extremes, whether it's heat or cold.
Okay, so we've established this antenna is, well, a beast of hardware. It's the right tool.
But the sources are really clear. Even the best tool is useless if you install it badly. What are the common mistakes people make that just kill the performance?
It often comes down to the basics, really. Not getting that clear 140-degree plus view of the sky. People try to tuck it away behind a radar arch or too close to a mast.
Trying to make it look neat, maybe.
Yeah, could be. But you have to ensure you've got at least a 20-degree clearance line of sight from anything that could block the signal. Sometimes that means using special angled mounts to get the right view.
And assuming you get the physical install right,
Yeah.
you can't just switch it on and hope the best, right? Commissioning is key.
Absolutely non-negotiable. The sources lay out a two-step process. First, do a harbor test, check your speeds, check your latency when things are calm, get your baseline.
Okay.
Then second, you must do a proper sea trial, get the boat moving, put it through turns, different headings. You need to actively test how it handles those satellite handoffs while underway. You're basically proving it works in the exact conditions it was built for.
Right. Stress testing the system in its natural environment.
Exactly.
And this brings us to something crucial you mentioned earlier, redundancy. Even this high-performance FHP isn't always enough on its own for truly critical stuff.
For genuinely seamless connectivity, especially for things where even a tiny dropout matters, you need more. You really should integrate a secondary connection, a secondary WAN.
Like cellular?
Typically, yes. A good LTE or 5G connection using a robust cellular modem, something like a PepWave Max BR1 Pro 5G, is often used.
Okay.
But then you need something smart to manage both connections, the Starlink and the cellular. That's where an SD-WAN appliance like the MDS blender comes in.
Yeah.
It acts as a controller.
Okay, SD-WAN link bonding. These sound complicated. In simple terms, what does that controller box actually do?
Think of it like a super smart, super fast traffic manager. It's constantly watching the quality of both your Starlink connection and your 5G connection. If it senses Starlink is about to waver, maybe the boat rolls heavily, or there's a satellite handoff coming instantly before you even notice, it pushes the critical traffic like your navigation data or that important video call over to the stable 5G link.
So it fails over seamlessly.
Or it can even bond the connections, using both at once for more speed or reliability. It prevents those little micro interruptions that kill video calls or disrupt real-time monitoring.
And that capability, managing multiple links, is what makes things like dedicated video conference bundles viable on Starlink.
Exactly. It's all about maintaining that smooth, low latency experience, even if one of the connections has a momentary blip. Which, let's be honest, any LEO system like Starlink will occasionally have.
Right. Okay. So installation is critical. Redundancy is critical.
Yeah.
What about just keeping it running long term? Saltwater, as we said, is brutal.
It really is. That marine environment just doesn't forgive neglect. One source describes salt building up like concrete on mounts if you don't clean it. So routine maintenance, maybe every 3 to 6 months, is essential. It's not complicated stuff, usually.
Like what?
Wiping down the unit to remove salt and grime. Checking the mounts, the corrosion-resistant bolts and hardware. Inspecting the cable seals carefully for any damage or water ingress. And importantly, making sure the firmware is up to date. Outdated software is a surprisingly common cause of weird connectivity problems.
Good point. Okay, so we know the FHP works. We've seen examples, right? Reducing dropouts on yachts, keeping commercial vessels connected.
Yeah, the real-world impact is clear. On, say, a 25-meter yacht that's moving around a lot, it dramatically cuts down disconnections compared to older systems. For commercial ships, ferries, cargo vessels, it provides that continuous link needed for operational monitoring, keeping the shore office updated. It really shifts maritime internet from intermittent to reliable.
Okay, so let's try and synthesize this. Key takeaways. The FHP is tough, built for motion, handles heat well. Gen 3 is the pick for high-demand use. Installation needs care, clear sky view is paramount, and that sea trial isn't optional. What's the final thought, the maxim for someone wanting reliable internet at sea?
It really boils down to seeing it as a complete system. The antenna selection, the installation quality, the ongoing maintenance, and implementing redundancy with something like 5G backup, they all have to work together. You nail all those steps. If you miss one, you compromise the whole setup.
Right, the chain is only as strong as its weakest link.
Precisely.
And we touched on logging performance during commissioning, like signal strength, speeds, creating a baseline.
Yeah, we talked about moving maintenance from being reactive, fixing it after it breaks, to being predictive. And that starts with knowing what good looks like, proactively logging and measuring.
So here's a final thought for you, the listener, to take away. Think about that idea of proactive logging. How could you apply that concept, tracking key performance indicators over time, not just to your boat's internet antenna, but maybe to engines, generators, IT systems, anything complex you rely on?
How could you use that data to spot potential issues, degradation, before a failure actually occurs? That shift from reactive fixing to predictive maintenance, that's the ultimate path to reliability, isn't it? Spotting the weakness before it brings things grinding to a halt.
Something to definitely think about. Apply that knowledge, and we'll see you on the next deep dive.